Go through really quickly the area formulas for all these different circle-based shapes. Okay, let's start with the circle. Okay, so circle, most of you should be very familiar with the area formula, and it's simply pi r squared. Okay, we then went to semicircle. It's a portion of a circle. And what portion of a circle is it? Okay, a semicircle is half of a circle. And now when you're dealing with a semicircle, is the perimeter of a semicircle half that of a corresponding circle? No, because you have to take into account the diameter also, right? But what about the area? Is the area of a semicircle exactly half that of a corresponding circle? Yeah. That's the fraction or portion of a circle that you're dealing with, and so it just becomes half of the area formula. And now, semicircle was a more specific sector. Okay, but if you take just a general sector of a circle and you find its area, now what you need to find is you need to take into account the radius. You also need to take into consideration the arc measure. And the area formula for a general sector is some fraction of the circle. Anytime you hear that terminology, it refers to the fraction m over 360. And it's some fraction of a circle's area, which was pi r squared. So this is your area formula for a sector. Now, does this formula work for a semicircle? A semicircle has an arc measure of 180. So if you took 180 over 360 times pi r squared, does that equal the area for a semicircle? Yeah. So you don't have to memorize a different or specific equation for it. They're based on the same properties. All right, the next is an area of a segment. We're not really going to work too much with areas here because we'll wait when we get to the information about triangles. But here we do have to take into consideration that a segment simply is the area of a sector, which is m over 360 times pi r squared, minus the triangle that's removed. So the triangle that's removed is this shape right here. And the triangle formula is 1/2 base times height. Again, we'll talk more specific details about that in the next chapter. Okay. The final type of problem that you're going to see here is referred to as a band. A band is simply the region enclosed between two concentric circles. And so if you take one circle embedded within another, so it kind of looks like a little washer. The area of this entire shaded region, or the region between these two concentric circles, is simply found by taking the whole outer circle's area and removing the inner circle from that. So I'm going to label the outer circle as a radius of capital R. So that gives me pi capital R squared for its area formula. And then the inner circle I'm going to label as a lowercase r, so pi lowercase r squared. Okay, and so these are the formulas that you would use to find areas. Okay, now what I would like you to do is just really quickly look on page 77 in your book. The image that was used for this, you can even see it says that where it says area of, for the sector, it actually has area of a segment. And so if you look right in the middle of your page, okay, change the word where it says a segment, change it so it reads sector, and then just scribble out the part that says 1/2 base times height, and the area formula for the segment is written below. Right, so if you change that, the very middle formula right there, or equation, change it to sector, and then scratch out the minus 1/2 base times height, because it should be the area for a sector and not a segment. And does everybody see where that is? Okay. Here, look at the